Hi everyone, in this video we are going to take a look how to use this TinkerCAD to create a new circuit with our Arduino, and also how to code and embed those into the system. So in the last video we kind of have walked through how to get into kind of this stage, getting into our classroom, and this is going to be our main screen. So if you click this 3D design, you will be able to create basically like a CAD modeling similar to SolidWorks, and by clicking this circuit, here is going to be our home, and let's click this create a new circuit. And this will guide us into the screen blank here, and you can basically drag and drop these elements here and there, the LED and the breadboard, which is here. Oops. And here's our Arduino board. But more interestingly, you can also select Arduino from this drop-down menu, and then it actually shows some like default settings for us. And let's try using this one, the blink here. And by clicking this icon, the code, you'll be able to see the code, and because this TinkerCAD, it tries to also have middle school or even elementary school students learn these codings and also 3D design. They have created some kind of block, like coding blocks to create a code, but we're not in that stage, so we change this to text, and yeah, are you sure? Of course. And here shows the code that is already written for us. So basically this is something you will be able to see from the lab manual as well. Well, I just kind of realized that I use that word basically a lot while I was just watching the videos that I took, and well, maybe is there anything else that I use a lot, like a bad habit? Maybe you guys can tell me, or count how many basically I say throughout this video. Anyway, so this is the code, and without delay, how about we click this start simulation and see what this thing does. Okay, we can see that this LED is blinking on and off, on and off. And oh, there is also this small LED here. Wow, I didn't notice this. So we can see stop simulation, and we can see that this TinkerCAD is really emulating Arduino very well, because Arduino board, it also has a small LED here, and it seems like everything is here. Anyway, so what this code does was it was blinking this LED on and off. And let's take a look at the code together. So this part here is basically, it's just setting up. I just said that basically. And pin mode. Pin mode defines the function of the pin, and here we would like to define pin number 13 to be the output. So from now on, pin number 13 is going to generate some output from the Arduino board to the outside. Okay, and by the way, these functions have open and close these parentheses, and they also have these curly brackets. So things within the curly bracket is going to be the content of this function. So setup, within this setup function, you put this pin mode definition. And these semicolons, it's similar to MATLAB. These are used for ending your command. And then we have a loop here, looping function, and that one also opens up and closes with a curly bracket. And what it does is it is writing this 13 to be high. Well, not that high, but high here means it's you're basically turning something on, like having it to be 1 or turning on. Okay, again, we're from the digital world, so high, 1, on, they're all the same. Low, 0, off, they're kind of all the same. Okay, so 13 is going to be on, and then delay for 1000 milliseconds. So basically, again, there's another basically, you are waiting for 1 second, and then you are turning this 13 off by making it low, and then you're waiting another 1 second. And then you go back up, because this is a looping thing. So you go back up, and then you turn on, wait 1 second, turn off, wait 1 second, up. You see, now we are doing repeating this thing. So if you run this thing, yeah, this is on and off, on and off, on and off. And you can just test. Say, let's make it like 500. So it's not going to be like 0.5. Let's make it even shorter, 0.3. Then this should blink faster. You can see that this is blinking, blink, 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 0.3 seconds. Okay, so this is kind of the code here, and you can move these things around like these and change the color of the wires like that as well. But let's just take these things well, I just hit delete now. So code, go away, hide, and let's click this basic. And we're going to introduce this breadboard here. Okay, so this is more like the environment we have in the lab. And you can use those this scrolling wheel to zoom in and zoom out. And we have this LED, and we have that resistor, and what else? Yeah, so let's play around. Okay, so I would like to use this rail, this minus, as our ground. So you click this ground and then pull it out. Well, you can see this is moving around. Okay, I just want to have it vertically up and click. And then that is going to be pivoted there. Click again, click, and then you hook it to the negative. Oh, now it's a little bit organized, looking neat. And let's change the color to black. That easy. So from now on, this whole line is going to be the ground, because it's connected to the ground. And let's move this thing to the breadboard. By the way, this, like I said in the other video, it has LEDs has polarity. It's a diode. So the cathode should be connected to the ground, and the anode should be connected to your signal. Okay, so let's just have it here. And this cathode, the short one, goes to the ground. Okay, and let's make it black. And then we have our resistor, and you can change the orientation by clicking this icon at the top left. Okay, so now better. Okay, so we have ground connected to the cathode, and then through that anode and the resistor, and this one, let's pull this guy into number 13, because in our code, I'm just trying to use this code, reuse that again, because this code was saying pin mode 13 is going to be our output. Okay, And this should work as same as before as we had. If you click running and then it's blinking, you see? And at this stage you cannot move this your things around because your code is running. So you have to stop the simulation, and from there you can drag and drop and have it connected. Okay, and you can also change the value of these resistor. Let's put it 470 ohms, and probably, I'm not sure, but probably this is a little bit brighter. And the reason why we have this resistor is that we want to say this LED is not blowing up. If you don't have this resistor, let's just delete this, and this one, let's pull it directly to the LED, and let's see what happens. It might blow up or not. Oh, it's not blowing up, but you have a warning sign, and it's going away, so it's not easy to read, but probably it's gonna say, hey, you're exceeding the maximum of this LED. Or maybe we can try another one, because it also has a 5 volts power source that comes out. So why not we directly connect it, and this one goes to the ground. This is something that I didn't plan to do, but let's see. If you run it, oh, the LED has just gone. This is burnt, and it's cute. And let's see. Let's take a look around and see what we have here. Oh, we have a multimeter too. Let's try this. So just drag and drop, and we can measure the amp. Oh no, we have to change it here. So we can measure the amp, voltage, and the resistance. So let's pull back our resistor. It was here, right? So rotate it. Oops, I rotated too much. Then it's gonna be here back, and you go back there. Okay, so now we have this circuit. It's coming out from 13, going through the resistor and through the LED, and it goes to ground, and they're kind of connected like that. Okay, so let's see if this really measured the resistance. Okay, I have put 2 wires across this resistor, and let's see if we start the simulation. Oh well, it's changing because there's current flowing, but then let's take this thing out, and let's just have another resistor. Okay, this one connected there, this one connected here, and the value was 1K. Let's put some silly number, 754. Okay, ohms. Let's see if this is really reading. Oh yeah, it's reading 754. Okay, so this is working well. And we can also measure the current across. Or let's measure the voltage across this resistor. And multimeter, we change it to measuring the voltage, and let's see what happens. Oh, the voltage is changing because it's turning on and off, so that's the reason why it's changing. And also we can see the current that is flowing. Yeah, the current is also fluctuating because you're turning on and off. Okay, so this is kind of a demo to show how this TinkerCAD kind of works. And you can create another code just like what I did for getting the deliverables. Uh, like I specified in the other another video of the introduction to the Arduino. There I told you we need to do deliverable 1 through 4 from the lab manual, and I hope this video helps you to get a good start.